this is a pretty challenging antiderivative that we ran into problems with in my class, so let's go ahead and solve it. Now, for reasons that you'll see in a couple of minutes, I'm going to just rewrite this as, pardon me, not du, dx. I mean, maybe you can see where this is going now. Okay, I'm going to rewrite this as dx over square root x plus 1. Okay, and then I'm going to let u be equal to the square root of x plus 1. And that means that du is going to be 1 over 2 root x dx, but I don't really see that anywhere. So I'm going to do a little bit more work, and I'm going to solve for dx. But the whole point of u-substitution is to completely change the variable into u's, and so I don't want that square root of x sitting there. So what I'm going to point out is right here that the square root of x equals u minus 1, right? So I could just make that substitution, and now I'll be ready to go, right? Because now I'm going to be having, okay, this integral, the original integral is going to be equal to the antiderivative of, okay, so we said dx is 2 times u minus 1, and then we're dividing by u, okay, and taking it with respect to u, right? Yeah, 2 times u minus 1 times du is dx, okay? So now I'm going to do a little bit of division. So this is 2 times the integral of 1 minus 1 over u du. Okay, and now it's pretty much, we're going to be able to solve this one easily. So this is going to be 2 times u minus the log of the absolute value of u plus c. Okay, that's barely on the screen, but it is. And so now I can go back into x's, and I'll say, all right, well, u is square root of x plus 1. Minus the log of the absolute value of square root x plus 1, okay, plus c. Right, no, and I had 2 of these. Okay, so maybe I'll just factor out the 2 there and add plus. And I kind of like that one. That was just not the typical u substitution that we see. One thing I would point out is that, like if you go to Wolfram Alpha and you ask it for the antiderivative here, it's just going to give you, it won't have this plus 1 in there. I'm just kind of proposing that 2 times that 1, well, that just could be kind of like wrapped up into the plus c. So that's why it wouldn't look exactly what you would see on Wolfram Alpha, but it's close, and this is how you get there.